Hello student, how are you? I am Arunsir. Welcome to my channel Tuition. Today in this class, I will teach you the equilibrium of a body along rough vertical wall. Now student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the iitjee exam and NEET exam confidently with a good rank. Now let's start about the class. Today's topic is equilibrium of body along rough vertical wall. Suppose this is a vertical wall and a body of mass m. Suppose a block of mass m is is held against the vertical wall by applying a force. So first I consider the force is applied along perpendicular to the vertical wall. Now coefficient of friction is given, static friction, so mu s is given. Now find minimum force required to hold the body against the vertical wall. So this is the question. That is, the body is in equilibrium under the vertical wall if a force is applied along normal to the wall. So find this force. To solve this problem, here what are the different forces acting? This block try to move downward along the vertical wall, try to move downward. So this is the force mg for which the body can slide downward along the vertical wall. The body can move downward along the vertical wall due to this force mg. Now the friction prevents this slipping. The friction F act upward, prevent the slipping of the body to move downward along the vertical wall. So what is friction? Friction, we know friction equal to mu into n, but here normal direction what? Normal direction is along in this direction. Here normal direction will be in this direction. Normal direction means at which the body is placed. Body is placed along this plane. Now normal direction is always perpendicular to the plane. When body is placed in the ground, when the body is placed in the ground, then this is ground. So normal direction, that is normal to the surface, is in this direction. This is normal. So for this reason n equal to mg. But here the body is placed along the vertical wall. The body is placed along the vertical wall. So what is the normal direction? Normal direction will be normal to the surface. So this is the normal direction. Now this force cannot be equal to mg because this and this act in two different directions. So this cannot be equal to mg. So what is the n? N will be, for n to produce n, a force required to act along this direction such that the normal direction, that is from Newton's third law, normal direction is developed at this contact surface. So here r equal to m, r or n. So normal direction n produced due to the force applied. So normal direction n equal to f here. So now friction equal to mu into f. So friction balance the weight, mu into f equal to mg. So f equal to mg by mu. This is the answer. A block of mass m, a block of mass is held by applying two force by two hand. Suppose by two hand we hold a heavy block of mass m. What is the force required to hold the body? The force required here, if a friction is present, then we can hold the body. But if not friction, if friction is not present here, that is for super smooth, then we cannot hold the body as we apply more and more force. That is, if we apply the sufficient force, infinite force, then we cannot hold this body if the surface is smooth. So there must be a friction at the surface to hold the body. So what is the force required? Minimum force required to hold the body. Here this is two surface. If this surface coefficient of friction is same, that is mu and mu, then here two friction act in this vertical upward, this and this friction F, so two friction balance the weight. So two friction balance the weight, that is 2 into mu, F equal to mu into mg. So here, sorry, 2 into F equal to what? F equal to mu into F equal to mg. So F equal to mg by 2 mu. That is here two surface present, so two friction acts along vertical direction, which prevents the weight of the body. Now next, now a block of mass m, now a block of mass m is required to hold against vertical wall by applying a force at an angle theta with vertical. Suppose this angle is theta, that is force act now in this direction. What is the minimum force required to hold the body, hold or keep the body in equilibrium against vertical wall? This is the question. What is the force required if the force act at an angle theta, or you can this angle okay. Now what is the force acting on this block? Weight act in this direction and the body on the vertical wall, so friction act in this direction. Now the friction prevents the sliding of the body along downward. So here also F act in this direction, so component of this force along this direction is F sin theta and this direction is F cos theta. Now what is the normal relation here? Normal relation, so if we equate this force and this force, we get normal relation n equal to F sin theta. There is no acceleration along this direction, so this must be equal to this, so n equal to F sin theta. Now this plus this balance the weight, so F plus F cos theta balance the weight mg into n is F sin theta mg, so F equal to mg by mu sin theta plus cos theta. So this is the answer. F sin theta balance the n. Now friction force equal to mu into n, friction force equal to mu into n. Now friction force plus F cos theta balance the weight of the body. So from this equation we get F. This is a vertical wall and in two blocks. This is a block of mass m1 and another block of mass m2. M2 is present. This is vertical wall. Now a force act along the perpendicular of the vertical wall, hold the two body. Coefficient of friction between this surface is mu1 and this surface is mu2. Static friction mu1 and mu2. Now what is the force required? Find F minimum to hold the two body to hold or keep the body in equilibrium against vertical wall. So this is the question. So if we consider the equilibrium of the mass m2, weight m2j act in this direction, so friction act in this direction prevents the block from sliding downward. So friction equal to what? Friction equal to here mu1 into F, which is equal to mu1 friction. Now this friction prevents the weight. So friction equal to weight m2g. Suppose this friction is F2. F2. So friction equal to this. This friction prevents the m1. This is mu1. This is mu2. Okay. So this is mu2. This friction prevents the weight of the block from sliding downward. Now what is the action? If suppose this, if we draw the free body diagram, m1 and m2, the force act in this direction. So this block push a action, and this is the reaction. As there is no motion in this direction, so R equal to F. So here R produced and normal reaction N produced by vertical wall, so N equal to R. So N equal to R equal to F we get, because there is no movement or acceleration along this direction, so N equal to R equal to F. F is applied force. Now what is the different force acting on M1? M1G act in this direction, and friction force. So if friction force act in this direction, then M1 friction here friction force act in this direction, because to hold the block, this is a contact phase, weight of the body act in this direction, so the friction must act in the opposite direction. Now if the friction act in this surface, in this direction, then the friction act along the surface must act in the opposite direction, because for every contact surface, action and reaction are equal and opposite. So this is friction force act in this direction, and this is the now F2 and weight act downward direction, and here a friction force along the contact surface of body and wall act in this direction. So this is suppose F1. Now here F1 balance this force and this force. So for M2, what is the different force? Here M1G act and F2 act in this direction. So friction act in this direction, which is equal to friction equal to mu1 into F. What is mu1 into N, which is equal to mu1 into F. So here friction force equal to this. So this friction F balance this and this, M1G plus F2. Now what is F2? F2 equal to M2G. So F equal to, what is F? F equal to M1 plus M2G by mu1. So mu2 here, mu2 is not required, mu2 is not required. So this force must be this. Force required is this, M1 plus M2G by mu1. So this is the answer. When force F is applied, then a friction act in this direction. This friction prevents the weight. What is the friction? Friction equal to mu2 into F. So suppose that friction equal to F2 equal to mu2 into F, which is equal to weight for equilibrium of the mass M2. Now for equilibrium of the mass M2, this will be equal. Now for the mass M1, what is the friction force? Friction force equal to this surface, mu1 into F, equal to mu1 into N equal to F. For this relation, mu1 into F. So friction force acts in the direction, weight act in the direction, and along this friction force act in the direction. So F1 equal to this plus this plus this, F2 equal to mg. So now F equal to this by mu1. This is one problem. Suppose here two vertical wall is present and a man is at rest. The man is at rest between two vertical walls by pressing one wall A by his hand, hands and feet, and the other wall B by his back. So this is wall B and this is wall A. So the man press this wall by his hand and feet and press the wall B by his back so that the man can be at rest. Now what is the force? For what force he must apply to the wall so that the man can be at rest? So what is the force applied at here so that man can be at rest in the wall, to vertical wall, and given mu equal to 0.8. This is the HC Verma problem. So what is the solution of this? Simple solution. So if the force is F here, then this force, same force, F and F. So suppose feet two force is F by 2 feet. F is force by 2 feet, and 2 feet together, 2 feet together. So total force is F by his feet, and hand together. So total force applied by his hand is F, and force applied by his back towards the wall will be 2F, such that to keep the body so that in horizontal direction net force is 0. So if this force is F, this force is F, then this force must be 2F. Now this is the two. Now what is the weight of this man? Weight of the man is mg, which is equal to 40 into g10. This Newton act in the vertical direction, vertically downward. Now friction force act in this direction, prevents the man sliding down, prevents from sliding down. So this is friction, and so what is the force? Friction force here. Here friction force is mu into F. Here friction force is mu into F, and here friction force is 2 mu into 2F. Total friction force act vertical upward. This and this force prevents the weight of the man. So 4 mu F equal to 400, that is F equal to 400 by 4 into mu. What is mu? Mu equal to 0.8, that is 400 by 8 into 10. So F equal to 125, 100 by 8, 125. Now what is the force? The question is what, find the normal force exerted by either wall on the person. Either wall. So what is the normal reaction by each wall? Each wall normal reaction is, normal force is exerted by either wall on the man is 2F. Normal force exerted by either wall on the person is 2F. So answer is 2 into 125, that is 250 Newton. This is the answer. Student, this is the end of the class today. To get such type of video, subscribe my channel. Okay, thank you.